Now the question before us is, a study was conducted to find out the concentration of sulfur dioxide in air in parts per million of a certain city. The data obtained for 30 days is as follows: 0.03, 0.08 and so on. Make a group frequency distribution table for this data with class intervals as 0.002, 0.04, 0.04 to 0.08 and so on. Now what is the question? The question is this, that a study was conducted to find out the concentration of sulfur dioxide in air in a certain city, and the data of 30 days was collected, and now we have been asked to prepare a grouped frequency distribution table. What it means? That we are to build a table showing the concentration of sulfur dioxide in the air. Now one option is that we write that on first day it was this, second day it was this, and then the data will become, table will become very long. So here we are to form a grouped frequency distribution table. That is, we will make a group, say up to 0.04, then next up to 0.04. In this way we are to make small groups, just like 1 to 4, then 4 to 8, then 8 to 12, this one. So while what is the answer? Now we start. Now in this question it is also written that the class intervals are mentioned. So first of all we will have to find out that when we are to design the table, up to which point we are to form the table. That is, up to which class interval we are to form the grouped frequency distribution table. So for this purpose we are to find out what is the minimum value and what is the maximum value in the data. So we will here find out, we see that minimum concentration of sulfur dioxide is equal to minimum concentration. We will find out, here it is written as 0.03. We will find out whether any item is less than 0.03. This is 0.03, 0.02, 0.02, this is 0.01. Anything less than that? No. So we find that the minimum concentration of sulfur dioxide is 0.01. So now we will also find out maximum concentration. Maximum concentration 0.08, more than that 0.09, 0.17, 0.18, 0.20, 0.22, 0.22, not more than that. So maximum concentration is 0.22. So we will have to make the class intervals which cover the maximum concentration up to 0.22. So we will make class intervals as, we first will be, which will be covering 0.01. So we will have to start from 0.00, 0.002, 0.04, 0.04 to 0.08 and so on up to the point which covers the 0.22, and that will be 0.22, 0.24, so that this entry of 0.22 is also covered in the frequency table. So now what the data is about? This data is about concentration of sulfur dioxide. So we will start forming the grouped frequency distribution table. So we will write concentration of sulfur dioxide. So we can write sulfur dioxide as SO2 ppm, parts per million. So now we will also have to count this data, that is what the particular entry falls in the particular class interval. So for that purpose we will write tally, and we will have to consolidate all the items which fall in the particular range. So here we will write frequency or number of days for which the concentration of sulfur dioxide was falling in the particular range. So number of days, or we will write it as frequency. So this is the table which we have started forming. It will have 3 columns. So first will be 0.002, 0.04. Next will be from this 0.04 to 0.08. Then it will next will start from 0.08 to 0.12. That is, every class interval will have the gap of 0.04. Next will start from this 0.12 to 0.16. Next will start from 0.16 to 0.20. Next will be 0.20 to 0.24. We will form the table up to 0.24 so that the maximum concentration of sulfur dioxide is covered within this table. So this will be the table. We will also have to make the total for how many days we have counted. So now the first is 0.03. We will find out in which class interval it falls. 0.03 falls in this. We will make the entry of the same. We may add that if a particular item, say it is 0.08, we will not count it in the second class interval. For the we clarified first, make and lines we draw so that we may not become confused when we consolidate the data. So now if the entry is 0.08, we will not count it in the second class interval, because as it is the tradition that we do not count the entry here. It will be counted in the next slab. If we count it in the second class interval, then it 0.08 is also appearing in the third class interval. So if we count 0.08 here, it will be again counted in the third interval, and it will result into the duplication of data, and our answer will become incorrect. So as a matter of tradition, we count it as in the next slide, so next class interval. We here are to count only that entries which are equal to 0.04 to up to 0.08, that is 0.04 to less than 0.08. So first entry we have counted, next is 0.08. 0.08 we will count at here in this class interval. Next it is again 0.08. It is counted here. 0.09. 0.09 is counted in this. 0.04. 0.04 is not to be counted here, it is to be counted here. 0.17. 0.17 falls here. 0.16. 0.16 is to be counted here and not in this class interval as already told. 0.05. 0.05. This is the 0.05. 0.02 here. 0.06. It will fall here. 0.18. 0.18 will fall here. 0.20. 0.20 will not be counted here, it will be counted here, because anything which is equal to 0.20 or more than that but up to 0.24 will fall here. 0.11. 0.08. 0.12. 0.13. 0.22. 0.07. 0.08. 0.01. 0.10. 0.06. 0.09. 0.18. 0.11. 0.07, it will be counted here. 0.05. 0.07. 0.01, it will fall here in the first class interval. Now 0.04. 0.04 will be counted here. So now we will count the number of days which fall in the particular class interval. Now we will take the first 0.00 to 0.04. The number of days are 4. In the next class interval, 5 plus 4, these are 9. In the third class interval, 5 plus 4, this is again 9. In the next 0.12 to 0.16, these are 2. In the next, it is 1, 2, 3, 4. And in the next, it is 2. So now we will count the total number of days so that we may arrive at the conclusion that all the entries, that all the data has been accounted for while we have formulated the table. 28 plus 2, 30. So the data in respect of 30 days is given and all these entries are total as 30. So this is the group frequency distribution table which shows that for how many days the concentration of sulfur dioxide fallen within the particular class interval. So this is the grouped frequency table. Now the next is in this question is for how many days was the concentration of sulfur dioxide more than 0.11 parts per million. So we have to find out for how many days the concentration of sulfur dioxide was more than 0.11. More than 0.11. That is, here all the entries are up to, in this class interval, all the entries are up to 0.11, less than 12, but up to 0.11. So all the entries or all the data which from here to here, that is from 0.12 to 0.24, all the entries which come, that is 2 plus 4 plus 2, that is the 8 entries, that the data in respect of 8 days falls in this particular range. So we will here write the our answer for how many days. So our answer will be number of days in which the concentration of sulfur dioxide was more than 0.11 parts per million is equal to 2 plus 4 plus 2, because all these entries fall in the relevant range. 2 plus 4 plus 2, that is 8 days. This is the answer. We have formed the grouped frequency distribution table and also find out the number of days in which the concentration of sulfur dioxide was falling within the particular range which has been asked for in this question. Thanks for watching. If you like our course, please spare some time to give star rating to our course.